Hello. Today we'll be talking about the possible role of climate change on Campylobacter in Europe. So to start with, what is Campylobacter? Campylobacter is a non-spore-forming bacteria. Its two most common species are Campylobacter jejuni and Campylobacter coli, which account for 99% of Campylobacter cases are between these two species. Campylobacter lives worldwide and can inhabit the intestinal tract of a wide array of warm-blooded animals. These include chickens, goats, cattle, cats and dogs, people, and it is unable to reproduce outside the gut, so it almost acts as a parasite, in that it must be inside the host in order for it to reproduce. It has multiple exposure routes to humans, which include foodborne and waterborne transmission, as well as animal contact. Campylobacter also can be exposed to humans through animal feces, such as chickens, which can lead to transmission. So one thing I want to talk about is climate change. So climate change, there is a widespread agreement among scientists that greenhouse gases are causing climate change. According to Santer et al. 2019, we are 99.999% certain humans are the cause of this climate change. The past 5 years, in fact, are the warmest on record since the 1800s. In fact, the warmest year in the past, we've been an increase in the past 42 years, according to NOAA, with the highest temperature on record occurring in 2016. And one thing, over most of Europe, in this case, February 2019 is what I have here, average temperatures for the month were substantially higher than the average temperatures from 1981 to 2010. It was particularly warm towards the north and the eastern portions of the continent, and were most above Western Europe and Eastern Finland. This is important, especially when we consider that this itself is proof that the Earth is, for some reason, warming. And to further support that, Zemp et al. In 2019 claimed that the Earth's glaciers are losing 390 billion tons of ice a year. So, climate change's effect on food. Climate change can affect existing pathways or lead to the emergence of new pathogens in food through effects on animal husbandry, animal-to-animal transition, pathogen survival, and other mechanisms. These pathogens most likely to be affected by climate change are those of low infective doses. So one would think of Campylobacter as a low infective dose. And so here, when we look at this map adapted from McMichael et al. 2006, it gives us a general overview of the effect that climate change is going to have on the agriculture industry. And because of that, we are most concerned with the health effects and the changing incidence of infectious and non-infectious diseases. In this case, Campylobacter, and how that may be directly affected by climate change. So, Campylobacter is one of the main causes of foodborne illnesses in developed countries. It affects both adults and children in developed countries. This actually differs greatly to its effect in the developing world or low-income countries. Because in low-income countries, Campylobacter affects the majority of children. The majority of the people affected in these countries are children under the age of 5. And because of that, there's a belief that there is a gained immunity from infection when you're a child in low-income countries because of the prevalence of Campylobacter everywhere. Whereas in developing worlds, it's not as specific to demographic. Adults and children are both at risk because it is not as common in the environment, and so the exposure is not always there. So, in terms of the effect Campylobacter has on the developed world, the CDC attributes an estimated 76 deaths, specifically in the U.S., per year to Campylobacterus. Campylobacterus is the infection of Campylobacter. And Campylobacter is interesting in that there have been many dose-response studies done on Campylobacter, and it is believed that an exposure as little as 360 CFU could actually cause infection of Campylobacter. And diarrhea is a major symptom of Campylobacter, so a diarrhea infection may occur if a dose as little as 800 CFU. And this gets back to the idea that pathogens most likely to be affected by climate change are those of low infective doses. Based upon Black's by now famous study in 1988, Campylobacter would be classified as a low dose pathogen. In general, though, according to the CDC, the FDA, it is believed that the minimum number of ingested Campylobacter cells that can cause infection is thought to be about 10,000. However, as previously stated, these trials by Black in 1988 seem to lower the bar in that it is believed a smaller dose may actually lead to infection. The incubation period of Campylobacter is typically from exposure to the onset of symptoms 2 to 5 days. It's a very short incubation period. The disease caused by infections, as I previously stated, is Campylobacterus. And the most common manifestation of Campylobacterus is the self-limiting gastroenteritis, which some people call Campylobacter enteritis. And this is typically handled without the need of antimicrobial therapy. Autoimmune diseases are another potential long-term complication associated with Campylobacterus, and the most famous example would be Guillain-Barré syndrome, or GBS. However, Guillain-Barré syndrome is estimated to develop 1 out of every 2,000 Campylobacter, specifically Campylobacter jejuni infections, and they typically occur 2 to 3 weeks post-infection. Symptoms of Campylobacterus include fever, diarrhea, abdominal cramps, and vomiting. The stool of the infected individual may also be watery or sticky, and may contain blood. It may also have fecal leukocytes. Other symptoms include abdominal pain, nausea, headache, and muscle pain. And typically, Campylobacterus is self-limiting, so you don't need hospital intervention, and the disease typically lasts 2 to 10 years. 2 to 10 days, not years. One area where the foodborne outbreaks are really becoming common is in Europe, where it averages about 400 outbreaks a year. Not cases, that's outbreaks. So if we look at this graph, which shows cases of 5 major pathogens in Europe, you see Campylobacter is the third highest rate number of outbreaks in Europe, and this was from 2010 to 2017. And the number of outbreaks of Campylobacter is relatively stable, in about 400 each year over the course of that time frame. Salmonella is still king in that it has the largest number of outbreaks. However, Campylobacter is not something to be taken lightly, because if 400 outbreaks a year are constantly occurring, it shows that there is an issue that is not being presented. So, Campylobacter in Europe, as I said, in 2017, Campy was linked with causing 395 outbreaks in Europe alone. 1,445 people were affected in those outbreaks, and 207 hospitalizations occurred, as well as 1 death. The country that was most infected was in 2017, was Germany, which had 147 outbreaks and 552 cases of infection. Next was Slovakia, which had 117 outbreaks, and it had the only death that was associated with these outbreaks in a year. This was followed by France, which had 207 cases. The outbreaks in Germany were linked most heavily with the consumption of raw milk. And if we look at the graph, we see the actual incidence rates according to the CDC for 2017. According to the ECDC, which is the European Center for Disease Control. And you see the incidence rates of each country from Campylobacter. Now you'll notice that there is some overlap between the outbreaks and the actual incidence rates. However, because they're outbreaks, these are more large-scale infections, whereas these are individual infections. And with that, you can see Slovakia is up there, which makes sense because it had 117 outbreaks, and it has an infection rate between 50 and 100 people per 100,000 people. But in terms of the largest incidence rate in all of Europe, that would actually go to the Czech Republic, which had about 151 people per 100,000 people. So, where does Campylobacter and climate change become related? Well, Campylobacter has a strong seasonality in Europe. Seasonality, which leads many to believe an association with climate change, is highly likely. And if we look at this map, this graph, we can actually see the seasonality of Campylobacter in terms of the number of cases. From May till October, the cases are the largest, and there's the largest amount of Campylobacter cases in 2017. And then these are the means from 2013 to 2016. This is important because this is the summer months. And this is showing that overall Campy has a positive association with temperature. And this is not only has to do with the fact that changes in weather, but some scientists believe that this might have to do with changes in diet. So, when there's more sun out, it has been theorized that there's more barbecuing. And because there's more barbecuing, there is a greater risk of infection because the Campylobacter is able to survive on raw meat, specifically chicken. Chicken is the largest form of Campylobacter, and it was found that between 40 and 71% of all retail chicken has Campylobacter on it. And it tends to be lower in other meats, but outbreaks are still known to occur. And so with barbecuing and the cooking of meat, there's a higher possibility of being exposed to this. Another interesting aspect is that outbreaks of Campylobacter are more likely to occur in rural and vulnerable populations. So they're more likely to occur with older adults and younger children under the age of 5. They're more likely to occur in rural populations because of agriculture and the fear that the water is becoming stagnant and the Campylobacter is able to live in that. Now, so we are aware of the current transmission vectors of Campylobacter. As I previously stated, we have food, we have chicken, we have bovine, we have pets, and we have water. Another theory suggested by Cousins et al. 2019 is that fruit flies could also be a vector that can carry Campy. This is because flies are going to be directly affected by the idea of climate change. So, as I talked about, campy seasonality coincided directly with the warm summer months, and as the earth warms, there's more warm months, and so there would be more cases of campy, theoretically. Well, the same seasonality coincides with flies and how flies live, fruit flies specifically. So, in the UK, it was found that there is a high fly density and activity level that directly corresponds with campy seasonality. And because there's been correlations between flies of temperature and humidity and precipitation in the UK, it is believed that flies are able to transfer the campy pathogen from the feces of a different animal, such as a cow, and they are able to spread it to human by landing on the food of humans. And so it is estimated that at current carbon emissions rates, there will be an increase of up to 244% in the fly population by 2080 in the UK. And with that increase in the fly population, there's an expected increase of infection by 10.9% due to fruit flies by the same parameters of 2080. So this also kind of draws to 2017 Campylobacter outbreak in Denmark. So in Denmark, there were 4,257 cases of Campylobacter infection in Denmark in 2017. The true cases is estimated at close to 50,000. So one problem with Campylobacter is that because it is self-treated, there's severe underestimation. In fact, in Europe, there's an estimated 250,000 cases of Campylobacter every year. However, because of the lack of reporting, the majority of those will obviously go underreported. And so in Denmark, there were 2 outbreaks in 2017. They were both related to unpasteurized milk. And this caused 72 illnesses. So I draw this back to the flies because Campylobacter has been found in the intestines of bovine cattle. And in the intestines of bovine cattle, it's been theorized that the infection of the udder may serve as a basis for Campylobacter, specifically Campylobacter jejungi. Doyle and Roman found an incidence rate of 0.9% of Campylobacter in unpasteurized milk from dairy farms. And they found that 64% of dairy cows were positive for Campylobacter jejungi in their intestinal tracts. And it was found that Campylobacter can survive over the course of 14 days in unpasteurized milk. This not only supports the need of pasteurizing milk because the heat will kill off the Campylobacter, but one thing that is most likely occurring is the flies are getting into the feces of the cows and they're spreading it to other cows. And so, specifically in the instance of climate change, whereas the temperature increases and fruit flies increase, the spreading of Campylobacter in the agriculture field is more likely to increase because the flies are getting inside the feces of the infected cows and spreading it to other cows. And if 64% of dairy cows were already positive for jejungi, that number is only expected to rise with the rates of temperature. So this all gets to a bigger question on, is Campylobacter really being helped by climate change? Well, correlation does not equal causation. It is incredibly hard to study Campylobacter, and we to this day do not understand all the mechanisms of survival. And so this has all been proven with correlation and not causation. So just because the heat is increasing in temperature, we are unsure that Campylobacter rates will actually be affected by climate change, and we can only theorize. Many scientists actually view Campylobacter as fragile and easily killed. And that's because they are sensitive to temperature. They are sensitive to air in that they mostly live in anaerobic places like the intestinal tract, and they're unable to multiply as a host. And we're not really sure how they survive on food as it is. Murphy et al. Theorized that they may form a biofilm, and that biofilm may allow them to survive the temperature and the aerobic conditions. However, that itself is still unstudied. And in general, unlike many other foodborne pathogens, Campylobacter are apparently fragile organisms that are unable to grow in the presence of air, like I said, and multiply outside a human host. And because they're susceptible to a number of conditions, including temperature, we are unsure of the effect climate change will actually have on their ability to survive. And there's a quote from Murphy et al. That if it was the responsibility of a laboratory scientist to determine if Campylobacter could become a foodborne pathogen, it'd be the least likely candidate because of its fragility. However, this bacteria continues to prove science wrong, and Campylobacter continues to be a serious public health threat. And to add on to that, with the impending climate change of the Earth, it is possible incidence rates will rise higher than they already are, especially when the vectors of transmission, such as fruit flies, are already expected to increase. So here are my sources. There's actually 2 pages. And thank you for listening to this recording.